This is Mrs. Naslund, and today we'll be doing Unit 1, Lesson 3, Situation and Solution Equations. Our learning target for today says, I can write a situation equation to represent problems. Now, you might be asking yourself, what is a situation equation and a solution equation? Well, a situation equation shows what's happening in a problem, and the solution equation shows how we get to the answer. So they're very different things, and I'm going to give you an example of each of them so you understand how they're different. So here's our example problem. It says, Stacy invited 9 girls and some boys to her party. 16 kids were invited in all. How many boys were invited? So again, the situation equation shows what's happening in the problem. So we know that Stacy invited 9 girls. Okay, she invited 9 girls to her party. And we know that she invited some boys. Okay, so we're going to say plus. And we know she invited some boys, but we don't know how many boys she invited. Okay, and we know total that there are 16 kids at the party. Okay, so this is an example of the situation equation. This is telling us or showing us what is happening in the problem. It doesn't solve the problem for us, but it shows us what we know. We know there's 9 girls, we know that there's some boys, and we know there's a total of 16 kids. Now the solution equation is when we rewrite the equation to help us solve it. So when we see a problem like this, I always tell kids to think of the opposite operation. And what I mean of that is like the opposite of plus is subtract. The opposite of multiply is divide. And you want to do that operation on both sides to figure out the unknown. So in this case, I'm going to have to subtract 9 from both sides of this equation in order to figure out how many boys were at the party. So I'm going to say minus 9 and minus 9, and then I'm just going to rewrite that equation, okay? And so basically I'm taking this right here and I'm rewriting it. So I'm going to say there were 16 kids minus, I'll write kids here so you remember that that's what it is, 16 kids, you have to forgive me, writing on the computer is a little harder, 16 kids minus 9 girls equals the number of boys that we don't know yet. All right, so this is my solution equation because this will actually bring me to a solution. So when I go ahead and solve it, 16 minus 9, 16 kids minus 9 girls ends up equaling a total of 7 boys. So you'll see the difference. The top equation was just showing us what was in the problem, and that's the situation equation. And the bottom equation here, the solution equation, actually helped us solve the equation. So that's the difference between the two. So let's look at a couple of examples, and then we'll see some examples that have been done for us, and then we'll actually solve a couple more on our own. So here's some that have been done for us. It says, Kaya put 28 apples into 4 equal packages. How many apples were in each package? So her situation equation is, again, what we know. We know that she had a total of 28 apples. So on one side of the equal sign, I'm going to have 28. We know that she put them in 4 packages, but we don't know how many apples were in each package. And remember, when we see 4a like this really means 4 times a. It's just an abbreviated way of writing it. You'll see it a lot in our book this year, written as like 4a. It just means 4 times a, or the number times the variable or the unknown. In this case, it's the number of apples. Okay, so there's our situation equation. And now we want to try to figure out our solution equation. Remember what I said earlier is that what you'll want to do is do the opposite operation. So in this case, we multiplied. So the opposite is going to be dividing. So basically they divided by 4 on this side and they divided by 4 on this side. So we get the number of apples, here it is right here, the number of apples is equal to 28 divided by 4. Okay, that is our solution equation because we could actually solve it and get a solution. All right, let's look at another example. A muffin tin holds 18 muffins. It has 6 muffins down one side. How many muffins go across? Okay, again, we know our total is 18. So that's going to be on one side of our equation, okay, of our equal sign. That's the total number of muffins we have. We know that we have 6 muffins down one side, and we don't know how many it goes across. But if you think about how you would solve that, you'd want to do multiplication. So again, they did this writing it as 6m, which really means 6 times m equals 18. Okay, so again, that's our situation equation. It's showing us what piece of information we know, and now we need to turn it into our solution equation. So basically the m is on the other side of the equals equation. It's by itself on one side of the equal sign. So again, to get m by itself, I have to do the inverse or the opposite of what it says here. So instead of being 6 times, I'm going to do the opposite, which is divide on both sides. So I end up with m equals 18 divided by 6. That is our solution equation. All right, now we've looked at a couple of examples. Let's go ahead and try to do one together. It says write a situation equation and a solution equation using a letter to represent the unknown. Solve your equation, make a math drawing if you wish. All right, so it says 5 minivans took 40 students to the zoo. If each minivan had the same number of students, how many students are in each minivan? Okay, so again, we know the total number of students. We know that's going to go on one side of the equation, right? One side of the equal sign. There's 40 students total. And how many minivans did they take? If we go back, it says they took 5 minivans to the zoo. And we don't know how many students are in each minivan, right? That's the unknown. We don't know how many students. So we're going to times this by, and you get to make up your variable or your unknown. So in this case, I'm going to put an S because it's students, S for students, right? So 5 times the number of students should equal 40 students total. All right, that's our situation equation. Now for the solution equation, remember we're going to do the opposite operation. So here we times 5. So we're going to do the opposite thing. We're going to divide by 5. We have to do it on both sides because we need to get the students number all by itself. So I'm going to say students equals 40 divided by 5. Okay, because now I could actually solve this and I would know how many students were on each van. All right, good. And today we're not actually solving them. We're working on the situation and solution equations, but you can see that that would be very easy to solve now to get that number of students. All right, let's do one more here. 15 trading cards are arranged 15 trading cards are arranged in 3 equal groups. How many cards are in each group? All right, so again, we know our total. We have 15 total trading cards. All right, so I'm going to put that on one side of my equal sign. And we have 3 equal groups. Okay, so that equal group tells me that I'm going to have to multiply again. And I'm going to make my variable unknown. Since we're talking about trading cards, I'm going to put it as a C. So 3 times the number of cards equals a total of 15 cards. Okay, so that's my situation equation. Again, it's laying out the information for me. But now I've got to get cards by itself so that I can actually solve this problem. So again, we do the opposite of what we wrote in our situation equation, the opposite operation, which in this case is going to be divide. So I'm going to say C, the cards, is equal to 15. Again, I'm going to do the opposite operation, divided by 3. Okay, and then you'd be able to solve for the number of cards that were in each group. All right, great. Let's do one more. I'm going to have you do some of this one on your own. It says Amelia bought 36 tomato plants for his garden. He can fit 9 tomato plants down one side of the garden. How many rows across will the garden have? All right, so I want you to go ahead and try to solve and see if you can write this, not solve, try to write the situation equation for this problem. Okay, so go ahead and try to write the situation equation and we'll see how you did. All right, so we know that Amelia bought 36 tomato plants. Okay, so we're going to put that on one side of the equal sign because that's the total that he bought. And he could fit 9 plants down one side of the garden, and they want to know how many rows the garden will have. So we know that he can do 9 here, but we don't know this number here, right? This is our unknown, and we know that there's a total of 36. So we know that we need to multiply. And say 9 times, and we get to choose our own variable. I'm going to say T for tomato plants. So your situation equation should be something like 9 times T, or a variable you chose, equals 36. Now we want to rewrite this equation into a solution equation. So go ahead and try to do that. All right. So when we try to rewrite our situation equations into solution equations, remember we're going to do the opposite operation because we want to get t by itself or the variable by itself. So I'm going to say t equals, and then I'm going to say 36, because we know there's 36 total tomato plants, and I'm going to do the opposite operation. Instead of timesing by 9, I'm going to divide by 9. And then I would be able to solve this equation to actually figure out the number of rows that were in the garden. Great work! Today we introduced situation and solution equations.